So, good morning, everyone. My name's James Holden. I'm the director of the Cloud Analytics team, and I'm responsible for one of NetApp's latest products, Cloud Insights. So, if you've been following the Tech Field Day, there's the overview of what Cloud Insights does and how it collects information from the environment. What I'm going to do now is give you a little bit of deeper dive on how we do the environment for a Kubernetes infrastructure. So what we've seen in NetApp is a huge shift in the way that applications are being developed and delivered in the environment. We also have gone through this shift with our own product sets. I'm also responsible for an on-premises tool set called OnCommand Insight, and we wanted to port that product into the cloud, make it a SaaS offering. We saw a lot of our customers were clamoring for the ability to not have to look after on-premises infrastructure, not have to be responsible for upgrades, and SaaS was the way they wanted to consume, and they wanted us to deliver their reporting and monitoring capabilities. So we started looking at a journey of making OnCommand Insight run in the cloud. It was a monolithic architecture. Our developers were running on the full code base. They were all doing it in collaboration with each other. It was highly structured. It was a kind of partial waterfall, agile methodology with sprints, but version releases. That world, though, has changed. Applications now are really being delivered via microservices and containers. And the ability for developers has really kind of brought a new level of innovation into the game. And so what we've done with OnCommand Insight is made it into a new kind of infrastructure for Cloud Insights, all based on microservices, with different developers being responsible for different component sets, different code bases, and we're releasing it now instead of every 3 to 6 months. Every week we get new feature sets that are delivered. Now that freeing up is really only because we can now go to that microservice architecture. And as an ability to manage and orchestrate and determine what runs where, how it's running, is a real challenge if you're just using microservices on their own. So Kubernetes came to the forefront a few years back as the platform of choice for making sure that it was organized, it was running in the right place, there was the right number of kind of stateful components, stateless components, what replica sets were available. And so that ability to run an architecture and innovate faster is something that a lot of our customers have been clamoring for, and Kubernetes brought that to the front. Now, there's a huge challenge around these architectures is they're so dynamic. The fact that an infrastructure component isn't now a physical host running for years at a time, but it's a very transient container or a replica set that's now being spun up and then coming into existence and then being spun down minutes later, means that the job of monitoring and looking after that architecture has many-fold increased in complexity. So what we wanted to do is give the ability there we go, is to monitor that Kubernetes platform. So what we have here is how we actually do that. And what I showed in the earlier session in the overview is how you can actually download our Kubernetes collection agent, drop a small little YAML file or a Telegraph agent out there, and what it does is it sets up a daemon set that runs on the cluster. So it runs on every one of the nodes in the pod and starts then streaming data up to us via that Telegraph agent. So we're collecting everything from the node OS level, the file system, what's going on with the Docker, but we're also pulling in the kube state metrics as well. So we're getting a full end-to-end picture, then at a 10-second granularity of what's actually occurring within the Kubernetes environment. Now that data is fed up, and what we're getting is now the full picture of how the environment is actually running. So the benefit of Cloud Insights brings to the table is that it's got the Doesn't actually show that little laser pointer, does it? But it gets the full ability to look at the Kubernetes pods, the nodes, what's going on with the containers, how they're actually performing, all their kind of metrics in terms of what the replica sets are doing, the utilization of the containers, but it also can add on top of it the application services. So if you are running something like Kafka on top of it or Flink, we can see all those metrics. And we can also see the underlying stuff in the operating system layer and in the hardware layer. So if you're running it on premises, we can see all the way down to the back-end storage and hopefully the NetApp devices underneath it. If you're running it up in AWS, we can see all the way down to the EBS volumes at the back end. And so what I have here is some of the dashboards that we're actually running in our environment to monitor ourselves as Cloud Insights. So we're a SaaS product. We're running on Kubernetes. What I've got here is some screenshots of it. It's actually my QA environment. It's got 76 pods across 7 nodes, I remember. I can see how many stateful sets. I can see my persistent volume to claim ratios. I can see what my average utilization is. I can see what's going on in terms of my deployment versus my desired state. So I want to be able to save the organization money. I want to know what's going on. I want to know any kind of bottlenecks that are appearing in the environment. And so what we've done is we've configured these dashboards to kind of answer those key questions. So I have all the conditions of all the different nodes. I can see when it's out of disk. I can see when it's got memory pressure. And then I can start drilling down into those details and actually seeing how they're behaving, what they behaved like yesterday, anything new that changed. Is there any new containers that appeared on the pod? What's actually occurring? And in terms of a time range, we're now down at the 10-second granularity on these metrics. Very shortly, these are going to be real-time dashboards. They're going to be scrolling along and showing you how it's actually behaving right now. So I can see my pod utilization. I can see from a CPU perspective. I can see it from a memory perspective. Again, it's those key saturation points, the bottlenecks that are appearing in the environment. When's the CPU being pegged? When's the memory out of the range? And then if I wanted to break it down and look further into the groupings or underlying constructs, I can start zooming into the CPU of the actual containers themselves, and I can see how they're actually behaving. And you can see I've got my Telegraph agents that are feeding into this Kubernetes environment. I can see my Kafka. I can see the Flink that's on there. My Elasticsearch is my backend database as the container sets. And if I wanted to overlay their performance metrics, I can do exactly that. The other piece about saturation in my Kubernetes environment is at my disk or my network layer. So we've also got all the information on the traffic. I can break it apart by the reads, the writes. I can look at the transmits. I can look and compare them to my reads, see where it's coming from, and then drill down at which pod is actually having those behavioral. I can look at my I/O over time, and I can see how it's behaving. And again, back to that disk level and where it's actually coming from. Now, as I showed earlier, a lot of the stuff that we do is around monitoring, but we can also look at the optimization of that environment as well. So my final Kubernetes dashboard is all about the cost then. I can put a cost component against all those different resources. I can look at how much my EC2 instances are costing. I can then assign those costs and make judgment calls about how much is being spent and how it's being spent. So here I've got my memory, my compute cost, my storage cost, how much is available, what I've got left. But I can also then look at it in terms of a percentage of utilization. And again, it goes back to all engineers never want to see a performance problem, so they always over-provision. And here, my QA environment is no different. I can see my CPU utilization is woefully low, 22%. I'm never going to have a performance problem. My memory utilization, that's a little better, around the 50% mark, so okay. And as you can see, we are NetApp, and storage is free to our QA environments because we've got 0.01% utilization of all that equipment in the back end. because it doesn't cost anything for us. So we have the ability to look at all those different Kubernetes components, not only from a performance, but also from a cost perspective as well.